Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. Continuing with the study of special probability discrete distributions, in this session we are going to deal with binomial distribution and Poisson distribution. Earlier we have described what is a binomial distribution and how the probability mass function was derived. Actually, binomial distribution arises from the probability of x successes out of n independent trials, and it can be done in NCX ways. So, when there are x successes, the remaining is n minus x failures. So, using addition theorem of probability, the PMF of binomial distribution, a random variable x is said to follow binomial distribution if it assumes only non-negative values. Non-negative values means it depends on the number of trials. If there are n trials, x assume the values of x as 0, 1, 2, 3 etc. up to n, and its probability mass function is given by p of x is equal to x is NCX p power x q power n minus x, where x is taking the values of 0, 1, 2, 3 etc. up to n, where there are only n independent trials are conducted, and q is probability of failure and it is equal to 1 minus p. Then we will discuss some illustrations of binomial distribution so that you can understand the concept of binomial distribution clear. That is, 10 coins are thrown simultaneously. Find the probability of getting 7 heads and 3 tails. In 10 coins, we have to find the probability of getting 7 heads. The 3 tails are obvious. Although it is given as 7 heads and 3 tails, we have to find out only the probability of 7 heads, because when the 10 coins are thrown, 7 coins are showing heads, means it means remaining 3 will show tails. So, this is an adjoint, and at least 7 heads we have to find out the probability, at most 7 heads probability we have to find. Let us see how to do this problem. 10 coins are thrown. It means a coin is repeatedly thrown 10 times, or the n trials being conducted here as 10 trials conducted, or 10 coins thrown means each coin considered as one trial. So, here n is taking the value 10. First of all, we have to write down what does the values of n and p stands. Here the two parameters for doing problems in binomial distribution are n and p. You must be knowing the value of n and then p, then only we can enter into doing problems in binomial distribution. So, n is equal to 10, okay, and the coin is thrown. We are talking about the probability of getting so many heads. So, we will fix upon the success as getting a head. X is equal to number of heads. So, success we have to fix. Success is getting head. Okay. So, n is equal to 10 and x is equal to number of heads. So, x will take the values of 0, 1, 2, 3 etc. up to 10. Then we must be knowing the value of another parameter. One parameter is known, n is equal to 10, and p is a probability of success. Probability of success. Here success is mentioned as getting head. So, therefore, probability of getting head. When a coin is thrown, getting a head probability is, everybody knows, that is equal to 1 by 2. So, p is equal to 1 by 2 and n is 10 and p is 1 by 2. With this we can proceed further in doing the problem. N is equal to 10 and p is equal to 1 by 2. First subdivision is probability of exactly 7 heads and 3 tails. Okay. This is actually P of x is equal to 7. Before that we must write what is P of x is equal to x. This is a binomial distribution, although it is not mentioned in the problem as this is x is following binomial distribution. Whenever you have equal probabilities and and the probabilities of success and failure are such that p plus q is equal to 1, we can use binomial distribution. So, P of x is equal to x is NCx p power x q power n minus x. We will substitute the values of for n, p and q. Q is 1 minus p, right. So, 1 minus p is n is 10, p is 1 by 2 and q is equal to 1 minus p, which is equal to 1 minus 1 by 2 is also equal to 1 by 2. Okay. So, substituting the values, P of x is equal to x is 10 c x 1 by 2 whole power x and 1 by 2 whole power 10 minus x. Adding these two, we have 10 c x 1 by 2, adding the powers x plus 10 minus x. So, this is 10 c x 1 by 2 whole power 10. This is your P of x is equal to x. We will use this to find out P of x is equal to 7. Okay. How? P of x is equal to 7 is the first subdivision of probability of getting 7 heads and 3 tails, and this is equal to 10 c 7 1 by 2 whole power 10, and 10 c 7 1 by 2 whole power 10, using the calculator the value comes to be equal to 0.11719. Okay. The second subdivision is probability of getting at least 7 heads. At least 7 heads. At least means we must be using the symbol greater than or equal to. Okay. That is the mathematical notation for at least P of x greater than or equal to 7. We have to see whichever is closer to your calculations. P of x greater or equal to 7 means P of x is equal to 7 and P of x is equal to 8. This is P of x is equal to 9 plus P of x is equal to 10. Okay. P of x is equal to 7 is 10 c 7 1 by 2 whole power 10 plus P of x is equal to 8 is 10 c 8 1 by 2 whole power 10, 10 c 9 for the P of x is equal to 9 1 by 2 whole power 10 plus 10 c 10 1 by 2 whole power 10. Okay. Taking 1 by 2 whole power 10 commonly outside, you have 10 c 7 10 c 8 plus 10 c 9 plus 10 c 10. Okay. And this value from the calculator, it gives as 0.17188. Okay. Next, third, you are asked to find out the probability of getting at most 3 heads and at most 7 heads, right. You are asked to find out the probability of getting at most 7 heads. At most in mathematical notation is less than or equal to. So, P of x less than or equal to 7, and we can't use 1 minus because this is not complementary to the second subdivision because you have equality symbol. If it is only less than, then we can use 1 minus of P of x greater than or equal to 7 will give you P of x less than or equal to 7. So, less than or equal to 7, there are two ways of writing. One is P of x is equal to 0 plus P of x is equal to 1 plus etc. up to P of x is equal to 7. These are the values which are less than 7. Whichever is simpler calculation, we have to approach that. Finding these 8 values and then calculating is much longer. Therefore, I will take 1 minus the remaining. Remaining is P of x is equal to 8, P of x is equal to 9 and P of x is equal to 10. As already we have found out these probabilities, finding these 3 probabilities is easier compared to finding the 8. It will save time. So, 1 minus of 10 c 8 1 by 2 whole power 10 plus 10 c 9 1 by 2 whole power 10 plus 10 c 10 1 by 2 whole power 10. Okay, and this calculation gives you 0.94531. Okay, hence we have found out the answers for 3 subdivisions. The first subdivision is for finding the probability of exactly 7 hits. That answer is 0.11719, and finding the probability of at least 7 hits is 0.17188, and then this you have found out probability of at most 7 hits. At most 7 hits is 0.94531. Next illustration is again with respect to binomial distribution, although it is not mentioned in the problem. Whenever you have equal probability or such that probability of success and failure is p plus q is equal to 1, we can use binomial distribution. Okay. A multiple choice test, as many of you have attended competitive exams, you could see the multiple choice test consisting of only 8 questions with 3 answers, 3 subdivisions, okay, to each question, of which only one is correct. You have to tick the correct one. A student answers each question, he is not sure about the answer. Each time when he wants to answer, he rolls a balanced die and checking the first answer if he gets 1 or 2, and the second answer if he gets 3 or 4, and third answer if he gets 5 or 6. To get a distinction, the student must secure at least 75% correct answers. What is at 75% correct answers of total 8 questions? So, he must be getting, to get a distinction, 75% of 8 is 6 questions he must be correct. Okay. If there is no negative marking, the question is, what is the probability that the student secures a distinction? He will secure the distinction only if he gets 75% correct answers. 75% correct answers will appear only when answers 6 questions as correct. We will do this problem, and since there are multiple choice questions with 3 subdivisions, getting 1 is correct means the probability of success is getting the probability of getting 1 answer to be correct. First of all, there are 8 questions, therefore n is equal to 8, and the probability of success x is getting correct answer, getting correct answers. That is a success, that is your success, and x is taking the values of getting correct answers with 0, 1, 2, 3 etc. up to 8, and there are 3 questions, 3 subdivisions, out of that only 1 will be correct. So, the getting correct answers is 1 by 3, p of p is equal to 1 by 3, and q is equal to 1 minus p is equal to 1 minus 1 by 3, which is equal to 2 by 3. With these values, we will have to work out the problem. What is the problem? You have to get at least 6 correct answers. First of all, we will write out the binomial distribution. P of x is equal to x is ncx p power x q power n minus x, that is 8cx 1 by 3 whole power x into 2 by 3 whole power 8 minus x. Okay, this is p of x is equal to x. You must answer at least 6 correct answers equals to 75% correct, which implies it is distinction. As mentioned in the question, 75% correct answers means it is distinction. So, what is the at least 6 answers to be correct? What is the probability of getting at least 6? As I already told you, 6 correct answers out of 8. As I already told you, what is the mathematical expression for at least, which is greater than or equal to 6. So, greater than or equal to 6 means p of 6, x is equal to 6, and p of 7 and p of 8. What is your probability? 8c6 1 by 2 whole power 6, 1 by 3 whole power 6 and 2 by 3 whole power 8 minus 6 plus 8c7 1 by 3 whole power 7, 2 by 3 whole power 8 minus 7 plus 8C8 1 by 3 whole power 8 and 2 by 3 whole power 8 minus 8. This calculation is 8C6 into 1 by 3 whole power 6 into 2 by 3 whole square plus 8C7 1 by 3 whole power 7 into 2 by 3 plus 1 by 3 whole power 8. This calculation gives you the answer 0.0197. Let us have a break. Welcome after the break. Earlier to the break, we have discussed the binomial distribution probability mass function, and then we started discussing the illustrations of a binomial distribution. Continuing with the illustration of binomial distribution, we will work out one more problem, that is out of 800 families. Here the frequency is given. It is totally different from the previous two problems. Out of 800 families with 4 children each, how many families would be expected to have? Here the question is not finding the probability. Here you have to find out number of families that is expected to have 2 boys and 2 girls. For finding the number of families, you must find out the probability, and the probability when you multiply with the frequency is here 800. You can see there are two numbers, one is 800, another one is 4. So 800 family stands for the frequency, that is capital N, and 4 stands for the number of trials, that is 4 children. Here n is equal, small n is equal to 4. And how many families would be expected to have 2 boys and 2 girls? As we have discussed in the first problem, and getting 7 heads and 3 tails. When 10 coins are thrown, 7 heads means obviously 3 will be tails. Here also, out of 4 children, when you are asked to find out the probability of 2 boys, 2 girls are obvious. So this and 2 girls is just an adjoint to you, and at least 1 boy, at most 2 girls, and children of both gender you must find out. Assume equal probabilities for boys and girls. When you have this hint, equal probabilities for boys and girls, it means it is following binomial distribution, because P plus Q is equal to 1, right? Okay, we will work out this problem, and we have to stick on to the success. Either getting a boy baby is considered as success, or either getting a girl baby is considered as success. Universally, getting a boy baby is considered as success. Will work out. So here the capital N is equal to 800, that is the frequency, and small n is equal to 4 children, and we will consider the success as getting a boy baby, and x is take the value. There may be no boys in the family, 1 boy and 3 girls, 2 boys and 2 girls, 3 boys and 1 girl, and 4 are boys. So x will take the values of 0, 1, 2, 3 and 4. Okay, coming to the first question, and we have to find out what is P. P is equal to getting a boy baby, obviously compared with children, girl or boy. So there are only 2 possibilities, out of which getting a boy baby is 1 by 2. Okay, now we have the 2 parameter values, n is equal to 4 and p is equal to 1 by 2. We have the 2 parameter values, hence we can go further in calculating the probabilities. Okay, p of x is equal to x is ncx p power x q power n minus x. N is 4, 4cx 1 by 2 whole power x and 1 by 2. Q is also equal to 1 by 2, right, from this, and q is equal to 4 minus x. Okay, this is p of x. What is the first question? The first question is probability of 2 boys and 2 girls. 2 girls is not required, therefore probability of 2 boys, because 4 children, 2 boys means obviously the another 2 are girls. So p of x is equal to 2, 4c2 1 by 2 whole power 2 and 1 by 2 whole power 4 minus 2. we should have simplified it further as 4cx and 1 by 2 whole power 4, so that it will be easy for you to calculate. So, 4c2 into 1 by 2 whole power 4, what is that equal to? 6 into 4c2 is 6 into 1 by 2 whole power 4, and this is equal to 3 by 8. This is actually the probability. The question is not finding the probability. The question is finding the number of families having 2 boys and 2 girls. So, we have to talk about the number of families. Number of families with 2 boys and 2 girls equal to n into respective probability value. N into P of x is equal to 2. N is 800, 800 into 3 by 8, which is equal to 300, right. Then coming to the second subdivision, probability of at least one boy. What is the mathematical expression for at least P of x greater or equal to 1? P of x greater or equal to 1 is actually P of 1 plus P of 2 plus P of 3 plus P of 4. Finding this is comparatively larger when you find P of x less than 1. It is a complementary, right. P of x greater or equal to 1 is equal to 1 minus P of x less than 1, and there is only one value of P of x less than 1, that is 0. P of x is equal to 0. So, 1 minus 4c0 1 by 2 whole power 4. What is this answer? This is equal to 1 minus 1 by 16, which is equal to 15 by 16. So, what is the number of families? Number of families having at least one boy equals to 800 into the answer which you have got, 15 by 16. This is equal to 750. What is the third subdivision? Probability of at most 2 girls. The question is not about boys. Okay. Once we have fixed the success, we should not change the success according to the question. The success is getting a boy baby, right, and the question here, third subdivision, is about girls. The girls number should be equally compared with the boys number. So, what is that here? At most 2 girls means less than or equal to 2, right. That is 0 girl, exactly number of 0 girl in the, no girl at all in the family, 1 girl and 2 girls. And convert this in terms of boys. The family is having 4 children. When there are 0 girls in the family, no girls at all in the family, it means all the 4 are boys, and out of 4 children 1 is girl, means the other 3 are boys. You have to convert this in terms of boys because boys is considered as success. 2 girls means 2 boys. Hence, we have to find out P of 4 plus P of 3 plus P of 2. Don't do this problem with P of 0 plus P of 1 plus P of 2, that will be wrong because girl is not our success. Comparing this, the calculation becomes simpler when you take P of x equals to 1 plus P of x equals to 0. Okay, what is the calculation? 1 minus 4c1 1 by 2 whole power 4 plus 4c0 1 by 2 whole power 4. Okay, and this answer comes to be equals to 11 by 16, and hence we have to find out the number of families having at most 3 girls. We have not changed the question, we have changed the question in terms of boys. The question must be for girls only. Number of families with at most 3 girls is 800 into 11 by 16, which is equal to 550. Fourth subdivision is probability of children of both gender. That is the combination of girls and boys should be in the family out of 4 children. So, this is equals to 1 minus probability of children of same gender, isn't it? Same gender means only boys or only girls. So 1 minus P of all are boys and all are girls. So 1 minus all are boys means x is equal to 4 and all are girls means no boys, therefore x is equal to 0. P of x is equal to 4 plus P of x is equal to 0 equals to 1 minus 4C4 1 by 2 whole power 4 plus 4C0 1 by 2 whole power 4, and this answer comes to be equals to 7 by 8. So, number of families with children of both gender is equal to 800 into 7 by 8, which is equal to 700. Okay. Hence, we have found out the number of family having at least one boy. The answer is 750. First question is number of families with 2 boys, that is 300, and the second question is number of families at least having at least one boy, that is 750. A third one is probability of at most 2 girls, and that answer is 550, right? And the fourth one is number of children with both gender, that is equal to 700. Hence, we have found out the answer for 4 questions. Based on the discussion about binomial distribution and the illustration, this illustration can be done by you. The probability of a man hitting the target is 1 by 4. If he fires 7 times, what is the probability of his hitting the target at least twice? So, here n is equal to 7 and p is equal to 1 by 4. The 2 parameter values are known. At least twice, must convert this at least mathematically as greater than or equal to, twice means greater than or equal to 2. P of x greater than or equal to, you have to find out. What is the probability of hitting the target 5 times? So, P of x is equal to 5, you have to find out. And what is the probability of hitting the target at most 6 times? At most means P of x less than or equal to 6, you have to find out. Continuing with the study of special probability discrete distribution, in this session we have dealt with binomial distributions definition, and then some illustrations are worked out to understand the concept further. Thank you.